1BitClaw is a decentralized application platform built entirely on the Bitcoin SV blockchain. There is no central server holding your data, your identity, or your money. The app itself is a thin client. Every task, post, agent, and as you're about to see, every workflow lives on-chain as an OP, return transaction. The server only relays reads. It never stores state, and it never has custody of anything. At the core sits a library of smart contracts written in script 36 or so deployed, spend-tested contract templates covering turn-based games like poker, battleship, and card games, decentralized finance primitives like crowdfunding, escrow, and atomic swaps, token standards, and general-purpose utility contracts. Each one isn't just a specification on a whiteboard. It's a real, funded UTXO on mainnet, with state transitions enforced by covenant logic and verified by an actual spending transaction, not a database row that merely claims something happened. A companion command line toolchain lints, builds, deploys, and calls these contracts, and flags drift the moment a deployed contract's on-chain state disagrees with what the client code expects. On top of that sits the workflow engine you're about to watch. And the key idea is that a workflow isn't a separate product bolted onto the app. It's a branch of a mind map board. Any node, a document, a task, a payment, a smart contract call can become a workflow step. Steps are assigned not to user accounts, but to bare Bitcoin addresses, either to one person or to a quorum of several signers. A workflow can be simulated for free before it costs a single Satoshi, compiled into a chain of transactions, handed to a human to execute by hand, or handed to an autonomous, headless runner that executes it with nobody watching, and everything it does afterward is provable by anyone, just by reading the chain. What follows is one continuous, real run on Bitcoin mainnet, 4 browsers, 4 independent wallets, real transaction fees walking through exactly what that looks like end to end. Act 1 has already happened while we were talking. Alice created a workflow node, assigned it to Bob by bare address, and Bob signed his own completion transaction. No account required on either side. Now let's slow down because Act 2 is where it gets interesting. A quorum. This time Alice doesn't assign one person, she assigns a group. Bob, Carol, and Dave with a quorum of 2. 3 separate transactions go out, 1 per member, each one its own on-chain invitation. Nobody is told to wait their turn. Bob and Carol complete their steps in parallel. No coordinator, no queue. Dave never shows up. That isn't a failure. 2 of 3 is exactly what the quorum promised, so the gate opens without him. Act 3 is where the workflow starts making its own decisions. A transform step writes a value into the run's shared context. A branch step reads it back and picks a path left or right the same way an if, else would in any programming language, except both branches are already compiled into the chain before anyone chooses. Alice compiles this one for a different audience, not her own outbox, but the chain itself, headless. The whole process definition becomes public, readable by anyone, before a single step has run. Then she hands it to a runner, one signed instruction over the relay, and from here on, no human touches this workflow. The runner takes its orders only from the workflow's owner, and it's just software. Anyone could host one. The runner executes alone. And when it's done, we don't take its word for it. We go back to the chain and check. Did the path that was actually taken leave the trace it should, and did the other path leave nothing at all? It did. Exactly 1 branch fired. Act 4 folds money and access control into the same step vocabulary. A payment step isn't a request routed through a payment processor. It's one transaction, built and signed right in the browser, with 3 separate outputs for 3 separate people. Anyone can verify those 3 outputs independently. On a block explorer neither Alice nor this app controls. Granting access works the same way in spirit. Each grant wraps an encryption key for exactly one recipient. Who can read something is enforced by cryptography, not by a permissions table somebody could quietly edit. Escrow needs no third party either. Bob locks his own coins to Alice with a time lock. She can claim them any time. If she never does, Bob gets them back automatically once the clock runs out. Nobody is holding anyone's money in the middle. And revocation is honest about what it is, not a deletion, but one more record. Dave's access is withdrawn, but the fact he once had it, and exactly when it ended, stays provable forever. Which brings us to the real punchline. Everything you just watched, every assignment, every completion, every payment, every grant, and revoke is a transaction, in order, signed by whoever actually did it. There's no hidden database behind this app. The audit trail isn't a feature bolted on afterward. It is the backend. 4 wallets, 5 acts, dozens of real broadcasts, and not one line of custom backend code holding any of it together. If the company running this disappeared tomorrow, every workflow, every payment, every grant would still be sitting exactly where it was written, on a chain nobody owns. That's what building on Bitcoin actually buys you. Not a promise that the rules were followed, but proof.